So here is a short report on the findings of the DMC 13 GHz module multiplying up to 134 GHz. The DMC module is connected via a short length of coax onto a 13 to 27 gig multiplier from the Come in Handy box. That's producing 10 milliwatts output. The DMC was producing 10 milliwatts output, and this module is not terribly efficient. That's doubling and still only producing 10 milliwatts output. That goes on to an amplifier which is in that box. I'll just see if I can find what that looks like inside. This is an old printed circuit board of what's inside the second amplifier. It was a 24 GHz amplifier that produced about 100 milliwatts output, but all I'm getting today is about 4.5 dB gain, and there's about 25, 27 milliwatts coming out of it. So here it is again, and that's got a power supply on top, some matching screws in the guide, and then it's going into the block, the diode block that was handed round at Martlesham. Since the amplifier is waveguide 20 and the block is waveguide 22 input, there's a bodge transition. It's actually waveguide 20 with a waveguide 22 flange fitted to it. Now got a back on the waveguide, which wasn't there at Martlesham. And then on the other side we've got the output waveguide and the power meter head, and also a meter showing the bias current. So there's the power meter. It's on the 10 microwatt range, and if I put my finger on the multiplier just to cut off the RF, get in the right place, we can see it's probably about a microwatt at best. And the mismatch, if the tone is audible in the background, you can hear some frequency pulling taking place. Signal on the receiver, it's actually a megahertz low now. I set it up at about 10:30 and it was drifting at the rate of about 1 hertz a minute at 13 gigahertz, but it's increased somewhat, the amount of error. The frequency is very voltage sensitive, and I believe there is one ovened oscillator in the 13 gig brick and one oscillator which is just standard crystal, running at, on other units, about 14 megahertz. So that's responsible for the frequency shift. So just trying to find the tuning knob. It's there somewhere. So the receiver's about 5 or 6 feet away from the multiplier block. Just feeding the whole lot from a stabilised power supply, and just touch the fine voltage control, and it's completely up. There it is. You can tell how unstable it is with voltage. coming to the 13 gigahertz brick, if I trim the oscillator, the DRO, that's fairly docile. So it's supply voltage on the unstabilized oscillator, which is the stability problem. So I've relocated the equipment just in front of the door here, with the receiver now down the bottom of the garden. The door is worth about 10 dB of attenuation, so I shall open that before I go to the bottom of the garden to have a look at the received signal. Just before we go down, I've put an antenna on the diode block, which is around about 20 dB gain. So I'm now down the garden, and the receiver's reading around about S8, but I did increase the sensitivity of the S meter to make it easier to peak the dish up when I was doing previous tests. So there's the signal coming down the garden from the house. Bit of drift taking place. I think that's the temperature change on the transmitter end, but it's a tolerable amount for antenna tests and so on. One of the interesting tests is point the receiver at the shed door. You can just about hear a signal. And if I come round, and we get the obligatory piece of metal. There's a bit more signal. So in conclusion, we've got the DMC brick driving a doubler, driving an amplifier, producing about 25 milliwatts, going into the ×5 diode multiplier with an antenna about 20 dB, and on the receiver the horn gain is about 18 dB. The 1 microwatt on the power meter is probably in the region of 5 to 10 microwatts from comparing the measurement here with a more correct measurement made by Roger G8CUB. So hopefully that's an easy way to make an intermediate amount of 134 gigahertz signal.